This is a recording of some problems from section 3.3 in our calculus book. In the first set of problems, we're asked to find dy dx, or the derivative of y with respect to x. In the first problem, y is equal to negative x squared plus 3. Now, if I'm going to be very explicit about every single step of the process, I might say that in this first problem, we're going to take the derivative of both sides with respect to x. And of course, that follows that basic idea of algebra that whatever I do to one side of the problem, I do to the other. When I take the derivative of y with respect to x, I get y prime. I also get dy dx, and both of these are equivalent statements. We're explicitly told to find dy dx, so let's go with that notation. Now, on this other side, I'm looking at this, I'm saying, well, what rules do I have to work with? Well, I have the rule that says that if I see the sum, if I'm taking the derivative of a sum, I can break this up to the derivative of its individual parts. So let's break that up as the derivative of negative x squared plus the derivative of 3. Now, when I look at this next part here, I say, well, what rules do I have to do with this? Well, I've got a negative 1 multiplier. I'm going to pull that negative 1 multiplier out because I have a rule that says I can do that. And I also have a rule that says if I take the derivative of a constant, its derivative is 0. Lastly, I have a power rule that allows me to take the derivative of this. The derivative of x squared is 2x. So my conclusion is dy dx is equal to negative 2x. Now, in time, with a lot of practice, you should be able to go from this step to this step. But for the time being, I'm going to be explicit on every single step. Alright, let's take a look at problem number 3. In problem number 3, I'm told that y is equal to 2x plus 1. So what is dy dx? Well, two ways to do this. Again, I can either be explicit and say that this is the derivative with respect to x of 2x plus 1, and say that's the derivative of 2x plus the derivative of 1, and then say the derivative of 2x is 2 times the derivative of x. The derivative of 1 is 0 because it's a constant, or 2 times, and then the power rule says bring the power down, reduce the power by 1, in which case I get a 2. Now, I can do all those steps. I can do all those steps, or I could also say, oh, let's recall that the derivative, the dy dx, is another way of saying what is the slope at any point on this line, and we recognize that on that linear curve that the slope is 2. So let's go on to problem number 5. In problem number 5, we're still asking to find dy dx. We are told that y is equal to x cubed over 3 plus x squared over 2 plus x. Now again, if I want to be very explicit about what I'm doing at every step, I could say, okay, I'm taking the derivative of both sides of the equation. I would say that the derivative of y with respect to x is dy dx. I would say this problem really should be thought of as a bunch of little derivatives added together. And then I would say, okay, I got a constant multiplier of 1/3 here. I've got a constant multiplier of 1/2 here. And the derivative of x, I can use the power rule for that, and we end up getting 1. I get 1/3. I can use the power rule for this, and I end up with 3x squared. I get 1/2. I can do the power rule here, and I get 2x plus 1. Those cancel, leaving me x squared. Those cancel, leaving me an x plus 1. So dy dx is equal to x squared plus x plus 1.